In this video, we will discuss the basic workflow diagram for our example. The basic blocks that we are using are the PWM block that is based upon a timer, and we are also using an ADC for getting the sensor measurements from the current sensors as well as the voltage sensors. So what we do is that as we all know that we have a triangular reference signal in power electronics on the basis of which we can generate a PWM. So this black curve is the um, reference triangular wave. So what we do this does is it goes from 0 up to a certain period, then it goes back to 0, then again it repeats the same cycle. So this is the time period in clock cycles. It goes from 0 to the time period in clock cycle. So this is the reference triangular wave on the basis of which the PWM will be created. The second thing that we need for the PWM creation is the reference signal. So this red line represents the reference signal. So if this red line is the reference signal, so we generate a inverted pair based upon for this reference signal. So whenever we cross this line, whenever the black and red line cross each other, so when going up, this portion will be called the up counting mode. So it counts from 0 up to a time period. So this will be called up counter mode. So in the up counting mode, whenever it crosses this crosses the reference value, so the first channel will turn from 1 to 0 at this point. Similarly, as the signals are inverted, so at this time the channel 2 will turn from 0 to 1. As you can see, there is a little gap between green and the purple signal. So these are the inverted signals, but there is a dead band between the green and purple signal, which we have configured in our system. So the three-phase output for all the three legs is generated in the same manner. So this is this representation for a single leg. So whenever after it goes up to the time period, it will go down to 0. So this is called the down counting mode. It counts from the timer period then back to 0. So whenever the reference triangular wave crosses the reference value in this down counting mode, the channel 1 will turn from 0 to 1, while the channel 2 will turn from 1 to 0. After that, we have a timer reset event. So this is called the timer reset or timer rollover event. So it starts again, changes from down counting mode to up counting mode. So this is the timer reset event. So we configure the system such that whenever there is a timer reset event, another ADC conversion will be started. So if we take this instance for example, so here the timer will do its computation. Timer has rolled over from down counting mode to up counting mode, so the ADC conversion will be triggered. So all the ADCs will start conversion. They will sequentially, each one the ADCs A, B, C, D will start the conversions. Once all the conversions are done, we will have a we have configured it such that it will there will be an interrupt. So this is the end of all the conversions. Whenever all of the conversions has completed, it means that we have the data from all of the current sensors and voltage sensors. So now we go to the interrupt, and we can use this measurement or sensing to compute the PWM or the duty cycle or the reference red value for the next cycle. So in this control loop, we are computing the reference value for this next cycle. So this in turquoise you can, or blue, you can see that This is the timer reset event. So for this instance, we will calculate the timer update value, duty cycle value in this clock period. So we get the new duty cycle here, then we change the new value from here. So the new duty cycle will be applied from here. So it will then generate the new PWM. So this is a continuous process. We have a PWM, it can starts the conversion gets the values of the measurements, and then the measurements are used for computing the duty cycle for the next PWM to be generated.